So I'm going to start off with something that's familiar and then talk about how we actually get composite functions from there. Okay, so we're going to start off with something you've seen before. Okay, here's a function f of x, x squared plus 2x minus 4. Find f of 2. Okay, you hopefully remember how to do this, so why don't you give that a shot and then we'll see if you do, and then we'll go over it. Just taking a glance around, look like you did pretty good. So all you're really doing is substituting 2 in for x. Everywhere you see x, you put 2 in, right? So I get 2 squared plus 2 times 2 minus 4. That's 4 plus 4 minus 4, which is 4. How many of you had that? Very good. So the reason we're covering something like that now, or just talking about that now, is because what composite functions really are inserting one function into another function. So here we inserted just a regular constant, a regular number. We substituted that in for the variables. Composite functions are when we substitute a function in for a function. So this same idea, but with more complicated polynomials. This example, okay, that's why we did it, to kind of remind you of what you're supposed to do. The only difference is instead of taking a number and plugging it in for x, I'm taking an entire other function and plugging it in for x. Okay? So keep that in mind as you're working through that. That's why we did this, because this is something you're really good at and didn't have any problems with. As soon as we get into what you're doing today, now it's a little more abstract, but the process is really the same as what we're doing here. Okay? So when you get to problems, and so that's what this says. A composite function is made by using one function as the input value for the other function. So on that example that I gave you, 2 was the input value. Now we're going to have an actual other function that is the input value. One of the really important things is the notation for composite functions. So here's some of that. Okay. This means this open circle here it's not, so to distinguish between this and the multiplication sign that you did for your homework for today. Okay, this you'll see it a little circle, and some of you will want to call this fog. It's not fog. It's f of g of x, and oftentimes too, you'll see it written like this. So they did it with the brackets, but sometimes you'll see it with just a bunch of parentheses. Okay. F of g of x like that. Well, let me try to write it better, because that looks terrible. Let's go down here. F of g of x, and then, nope. Sometimes it'll look like that. Okay. They all mean the same thing. F of g of x. And here's what this all means. Okay. So before, for f of 2, the 2 was here, right? The input value was 2. But now the input value is going to be a whole other function, g. And so what this means is g of x is the input value into f. So when we get to a problem like this, let's just try to understand what this means. And think back to the problem we did where we inputted 2. Okay? What we're going to have is this other function g of x, that's going to be the input value. That's what we're going to take and substitute in for x, in f. Okay, just the way we did with the 2. Okay? Now, the other thing is it can be flipped around. You can have g of f of x, where now the input value is f. Okay? So this order really makes a difference. So like over here, f comes first, so g is inserted into f. Okay, over here, g comes first, so f is inserted into g, and this is another way to express it. I know. So keeping that order straight is really important. Making sure you're inserting the correct function into the other function. Keeping that order straight really matters. Okay. So this part of the 6-1 lesson is really, really important because it's going to play a role in the rest of what we do in chapter 6. Okay? So making sure that you take your time to do this correctly and ask questions if you're unsure is really, really important. Okay? That's going to be the key to your success here. So here's the type of problem you're going to run into. All right? We're not going to worry about the domain and range. So even though the directions will say that, we're going to just not worry about the domain and range. Okay? So you don't need to worry about that when we're working on it in our homework. But I wanted you to know that you're going to see that and that you can't ignore it. Okay? So I have two functions. I have f of x and I have g of x. They want us to find f of g and g of f. Okay, and in this case, since g comes second, g is the input value into f. In this case, f comes second, so f gets inserted into g. All right, and I think that writing it with the parentheses and not the little circle is preferred. I think that'll make it easier for you to do. So I think that's the way I want to do that. So here's what this means, okay? Instead of inserting a number into f, we're going to input another function. What this means is I'm going to take g of x and I'm going to stick it into f. Okay, so all of this is going to go into here. Okay, that's really what a composite function is. We're going to create a new function by substituting in. Now, here's what that looks like. Okay, so g, again here, g is the input value. So I'm going to insert g into x into f. So what that means is, just like what we did at the very first problem, you're only going to substitute where there are x's. So here there's only one place where there's an x. Right? So instead of substituting a number, we're going to substitute this function. And I'll show you what that looks like. Okay, so here's what it's going to look like. Now here I did switch to the parentheses. So really what we did is f of g of x. So this g of x replaces the 2 in the original problem from the beginning. Okay? Well, what does g of x actually equal? So compared to the other problem, we had f of 2. This is where 2 was, right? So f is x squared plus 2. So I took g of x and put it in place of x, just like we did when it was a 2. Okay, but what is g of x? What does it equal? X minus 6. G of x equals x minus 6. So in reality, what I'm going to do is I'm actually going to put x minus 6 in right there. Okay, and that's really what this is about. Okay, so I'm taking this g of x, it is the input value, it goes into wherever there's an x. And that's what I get down below. Okay, now I just have to simplify that and I'm done. And you have to be careful here. Okay, this does not mean square x and square 6. That's not what this means. That means I have 2 x minus 6's. So when I'm working this out, you're going to have to do it like that. So go ahead from there and finish this up. Multiply this out, combine like terms, and you'll be done. Okay? And then we'll go on and find g of f of x. Okay, so here's what you should have done. Follow that out, you get x squared minus 12x plus 36, and then plus the 2. So then the 36 and 2 is 38. So that's f of g of x. All I did is I looked at f. And what g was got substituted in everywhere there was an x. Okay? That's how we arrived at this. The only difference between this and what we did at the very beginning is we inserted a number. Now we're inserting an entire other function. And that's what makes it a composite function, okay? Now we need to do it the other way. So the other way means I'm going to take what f equals and substitute it in for g. Okay? So this is the other way, g of f of x. All right, so now, f is the input value. So now I start with g of x, and I'm going to take what f of x equals and substitute it in everywhere you see an x, which is only one place. Okay, so go ahead and try to do that one. Here's what you should have had. Okay, so really all I'm doing is replacing this x in g, because there's only one x. So that x gets replaced with the entire function x squared plus 2. Okay, how many had that? Good. All right. Since nothing is being multiplied by this set of parentheses, we can really just drop them. So it's really just x squared plus 2 minus 6, and then I have some like terms. Okay, so what's 2 minus 6? Minus 4. Okay, so that's g of f of x. Okay, so see how you're plugging one function into the other wherever there's an x? Now, I gave you a couple that weren't so rough because there was only ever one x. There's going to be functions like the first example I showed you, the f of 2, where we had to plug 2 into 2 different places. Sometimes that will happen. So sometimes you'll have to plug the function in to more than one place. But think back. Use that very first problem. I'm going to go back to it real quick. All right. Use that as a guide to kind of help you decide what am I supposed to plug in where, and just understand that instead of a 2 here, it's the entire function. Okay?